Yes. So today we will discuss about the calculation of the center of mass for the continuous system. That means when the mass is distributed. So in the last class we have discussed about the discrete particle system. So for discrete particle system we use a separate formula to calculate the center of mass RC. That should be equals to M1 into R1 plus M2 into R2 like that. Okay. So this is the formula that I have used to calculate the R coordinate or the position vector for the center of mass of the discrete particle system. Now these are the example semicircular ring or semicircular ring. These are the example for the continuous system. So where the mass is being distributed. Now for this situation, so the R coordinate or the X coordinate or rather say Y coordinate, the center of mass, that can be calculated based on the integration format. That will be equals to integration of x dm and divided by integration of dm for the calculation of x coordinate. Similarly, integration of y dm divided by integration of dm. So these are the formula that I am going to use to calculate the x position or y position of the center of mass for the distributed particle system. Now regarding the distributed particle system, so these are the different types of geometry that you should know what are the position of the center of mass. Now one of the important assumption before calculation this is that we, for any geometry, whenever I am considering the distributed particle system or distributed mass, we assume that the mass is uniform or mass is constant. Mass is constant. So mass is constant means now mass is distributed uniformly. Okay. Now there are three types of distribution that we should consider over here. Is that so? This is a geometry. Semicircular ring is a geometry where we say it is a 1D type of geometry. Okay, because it is like so hollow hemisphere, it is a 2D geometry. It is a 2D geometry because it is area geometry. So okay, because here for the hollow hemisphere we define the area. For ring we define the length. Hollow cone, it is again the 2D type of geometry. Okay, so these are the 1D geometry, this is the 2D. Then come to semicircular disc. So for semicircular disc, again I consider it is a 2D type of geometry. Solid hemisphere, we consider it as a 3D geometry. And solid cone, again, I consider it as a 3D geometry. Okay. So whenever the geometry is 1D, we define the mass density as a function of lambda. What is lambda? Lambda is defined in terms of kg per meter. Okay. For 1D geometry, we define the lambda as the mass density. There is a kg per meter is a unit. For 2D geometry, we define sigma as the mass density, that is kg per meter square. Okay, areal mass density. Similarly, for the 3D geometry, we define the rho as the density, that is the kg per meter cube, that is the volumetric mass density. So these are the three information that you should learn before proceeding this calculation. So depending on the nature of the geometry, either the geometry may be 1D category, or it may be of 2D category, or it may be of 3D category. So whenever the geometry comes under the 3D category, we should define the parameter as rho. What is rho? Rho is the mass per unit volume. For 2D geometry, we should define the mass per unit area, that is sigma. It is called the areal mass density, and it is called the linear mass density. It is the linear mass density. It is the areal mass density, and this is the volumetric mass density. So these are the three different mass density that we should refer to use over here. Okay. Now we apply the concept of this to calculate the first parameter is the for the semicircular ring. Okay. Now this ring is there whose mass is given as m and radius of the ring is r. You are asked to calculate the center of mass of this semicircular ring. Now this semicircular ring is symmetrical about the y axis. So whatever is the center of mass should lie on the y axis. Okay. So that means I should calculate only this y center of mass coordinate. So this yc has to be known because x coordinate of the center of mass is always equal to 0. Okay. So for that you should use the formula for the y coordinate. So how to take the element for this situation? So here I take a element by moving an angle theta in this direction. Now I take another d theta element like this way. So this becomes our element. Okay. So this is the element. Now what is the element? Element is the mass is dm. So for every element I define the mass as dm. So dm is the elemental mass. Now our task is to write the expression for the dm. Now what is dm? Now for this ring geometry, as I have already mentioned, the ring is basically a 1D geometry. 1D geometry. So for that I define the lambda parameter. What is lambda? Lambda is mass by length. Total length is how much? 2 pi r divided by 2, that is pi r. What is pi r? Pi r is the perimeter. So m mass is distributed over the pi r perimeter. So lambda is basically m by pi. Okay. So for this dm element, what is this length? That particular length is nothing but r into d theta. Now, so corresponding to this dm, can I write that is lambda into r d theta?
Yes, sir.
Lambda into r d theta is the dm. So now I can put the value of lambda. Lambda is m by pi r. So m divided by pi r into r d theta. Ultimately, r cancels out. So m by pi into d theta. So that is our dm value. Now, once I write the expression for the dm, next task is to write the equation for the y coordinate. So I know that y center of mass is equals to integration of y dm divided by integration dm. Now, what is the integration dm? That dm integration dm is nothing but the total mass that is given as m. Okay. Now, what is y? Here, the y is the y coordinate of the center of mass of the element. So, element has the center over here. So, what is the y coordinate? This much distance. What is that distance? That can be written as r sine theta. So, this is our y coordinate. Y coordinate is what? Y coordinate is the y coordinate of the center of mass. That is r times sine theta. Okay. Now, put it over here. So, ultimately, I am getting r sine theta in the numerator multiplied by dm number. Now, what is dm? dm I have already calculated, that is m by pi into d theta. And integration of this. Okay. So, in the numerator m is there, in the denominator m is there. So, m cancels out. So, only r by pi come out of the integration of sine theta d theta. Now, the limit. So, starting from this point, so this is the starting point of the ring is A and end point of the ring is point B. So, theta is varying from 0 to pi. So, integration limit from 0 to pi. So, sine theta integration is cos theta. Sine theta integration is cos theta with a minus sign. So, I can write r by pi with a minus sign cos theta. Now, limit is from 0 to pi. So, ultimately what I can write minus r by pi into cos of pi minus cos of 0. Now, cos of pi is minus 1, cos 0 is 1. So, minus 1 is minus 2. That means ultimately it gives 2r by pi. Okay. So, that is the y coordinate center of mass of this semicircular ring. Okay. So, ultimately you have to remember this formula, but the derivation is quite important. Why? Because for the entire derivation, I assume that lambda is constant. Now, lambda number is constant. I assume that it is constant number. But in the problem, it may be given that lambda is another function. Lambda is a function of theta or something other quantity is given. So according to that, lambda will come inside the integration. Okay. So that means the method has to be known depending on dependency of lambda. If lambda is a constant one, then it is quite easy to calculate. If the lambda is variable, then that thing has to be put under the integration symbol. Okay, then only you can do. So method has to be clear to you how you are approaching the problem to solve. Then only you can do for any type of variation. Okay. Now come to the second geometry, that is a semicircular disk. Now this semicircular disk is a kind of element which is called the 2D geometry. Okay, so for 2D geometry, we define the sigma number. What is sigma? Sigma is the m by area. What is the area? That is pi r square by 2. Okay, so area of the disk is pi r square by 2. So 2m by pi r square is our sigma. So first, for any geometry, either you define the lambda or sigma or rho, depending on the nature of the geometry. So once I define the geometry, define the sigma number. Now, how I taking the element? By moving a distance of y, I take an element whose thickness is dy. So this becomes a ring. Now, so this becomes the ring. That ring is acting as an element. So for this ring, let us say dm is the mass. Now what is the mass? Mass is sigma into dA. Now what is the area? Area is basically the circumference is pi into y. 2 pi y. So circumference is pi into y into dy. Why? Because if you straight it, if you open this ring, so this is the circumference. Circumference is semi-perimeter, that is pi into y. 2 pi r divided by 2 means pi r. So pi y, and this is the thickness is y. dy. Okay. So that means this is the area that I am talking about. That is nothing but the dA area. So sigma into dA, that gives the dm. So ultimately what I can write, that sigma, that is 2m divided by pi r square multiplied by dA. dA is pi y into dy. That is our dm number. Okay. Now once I calculate the dm number, now we have to put this game inside our integration format. So again, the geometry is symmetric about the y-axis. So only thing is that I have to calculate the y for the center of mass. Y coordinate of the center of mass, that should be equals to integration of y dm here by integration of dm. Again, the denominator gives the integration of dm in the total mass, that is the capital M. Only thing is that I have to take care about the numerator part. Now again the y parameter comes. What is y? Y is nothing but the center of mass of this element. Now for this element is a ring. Now I already know what is the center of mass of the ring. Center of mass of the ring is 2r by pi. In the last example, I calculated the center of mass of the ring. So for this elemental ring, y is basically 2r by pi. What is r? R is y. 2y by pi. Got it? So that y is nothing but our center of mass of the element. Element is ring. So for the ring, I know the center of mass of this elemental ring is basically at a distance of 2y by pi from this origin. So that 2y by pi is written in the numerator, multiplied by dm. Now what is dm? That is 2m by pi r square. I am writing the entire thing, that is 2m divided by pi r square into pi y into dy. Okay. So integration of this. Now again the numerator m and denominator m cancels out. So 2 into 2 means 4. Pi cancels out. So ultimately I am getting 4 by pi r square. 4 by pi r square into integration of y dy. Y square dy. Now this is the final answer. Okay. So y square dy into 4 by pi r square. Now what is the limit of y? Limit of y is 0 to capital R. So ultimately I am getting y cube by 4r. So that means 4r by 3 pi. 4r by 3. Okay, that is the y coordinate center of mass of the this geometry. Okay. So this is the way by which you can derive the formula. Once you derive the formula, then you should know what is the formula, because in the numerical you have to apply the formula directly. There is no scope to derive the formula. You have to remember the formula, but the method of derivation is very, very important. Okay, same method of derivation has to be applied every time, provided the sigma is constant or sigma is variable. If the sigma is variable, then also you do the same calculation. Only thing that here you should write this variation. Here I am writing only the sigma parameter, but in the question it will be given that sigma is a function of 1. So that function you have to incorporate over there. So this is the method. Now moving on to the next geometry. Now go for the hollow hemisphere. So hollow hemisphere. So here the catch is that hemisphere. Whenever I am saying hemisphere, the thickness, assuming that the thickness of this hemisphere is very small. So this is the, let us say this is the thickness. So thickness is very, very small.
Oh, here we take a part of thickness.
Yes, thickness is very small, but since the thickness is very small, so this is also referred to as a geometry which is known as the shell geometry. Shell geometry. Okay. And for shell geometry, again, we assume it is a 2D type of geometry. Okay, it is a 2D geometry. That means 2D geometry means here also I should define the parameter C, not rho. It is not a 3D geometry because the entire analysis is dependent on the situation that the T is very, very small. If T is very small, this number is very small, then only I can say the thickness is very small, that means the entire geometry is acting as a shell geometry, for which it can be assumed as a 2D geometry, not a 3D one. Okay. Now moving on to the calculation. So let us say this is a hollow hemisphere. So how to take the element? By moving an angle theta, then I am moving another d theta angle, and I am cutting this hemisphere. So now this portion is coming as the element. Now this shape of the element is, since the entire material is hollow, this is basically a ring element. No, it is not disc, it is the ring. So once I cut this hemisphere, so let us say this is the hemisphere. So if I cut this hemisphere in this manner, so the portion where I cut it, so this is the portion that is our element. So that element, how it looks, basically it is a ring, because the entire part, inside part is there is no material, so it is acting as a ring. So once I cut this hemisphere, I am getting an element called ring. So it is a ring element. So for that ring element, so I want to calculate what is the dm there. So dm for this ring element should be equals to how much? Dm should be equals to sigma into dA. Sigma into dA. Why? Because this is a 2D geometry. Now first we define the sigma. Now what is sigma? Sigma is the mass by area. So area is what? So 4 pi r square divided by 2 means 2 pi r square. 2 pi r square is the surface area of the hollow hemisphere. So sigma is defined as m divided by 2 pi r square. Now what is dA? So dA is the area of this ring. So if I say this is the ring geometry that I am talking about, this is the ring type of geometry. whose radius is this much. This is the radius. Okay. So what is small r? Small r is nothing but the arc or sine theta. Small r is r, capital R sine theta. What is the thickness of this ring? This thickness of the ring is r times d theta. R times d theta. Okay. So if I cut the ring, and make it straight, like this way, I get a rectangle like thing. So what is this? This is the total perimeter. That is 2 pi r sine theta. That is the perimeter. Okay. And this is the thickness. Thickness is how much? R d theta. So once I cut the ring, now I can estimate about the dA area of this ring. What is this area? That is 2 pi r sine theta into r d theta. That is the area. So once I calculate the dA, so dA becomes how much? dA should be equal to 2 pi r sine theta multiplied by r into d theta. Okay. So that is our dA. So I know the value of dA. I know the value of sigma. So put it over here. That is the value of dm. Okay. Now again, this is a geometry which is symmetric about the y-axis. So again, I have to calculate only the y coordinate of the center of mass. So y coordinate of the center of mass is equals to integration of y dm. In the denominator, it is integration of dm. Again, this denominator dm is basically our capital M. Okay. Because every time the capital M is given, total mass is assuming that M is the total mass of the body. So M is given. Now what is y? Y is the y coordinate of the center of mass of the ring. Now I am getting the entire ring, not the half ring. I am getting the total ring. So center of mass is over here. So center of mass is over there, means it is at a distance of y from the origin itself. So it should be simply y. And then dm is that number. So I am writing y into dm means 2 pi capital R sine theta into r d theta into sigma. Now sigma is m by pi r square. Integration. Okay. So again m and m cancels out. So pi cancels out. So r square also cancels out. So we are left with basically 2 times of y sine theta into integration. 2 times of y sine theta into d theta. Okay. Now, what is y? Y is y. Now sine theta, or rather y can be written as r cos theta. Y can be written as r cos theta. So I can write 2 times of r cos theta into sine theta into d theta. Okay. So that means the entire integration now comes under the formation of the theta. Theta is the only variable. So r is constant. So that means 2 sine theta cos theta means sine 2 theta. So ultimately what I am getting, yc is equals to r times sine of 2 theta d theta. Now what is the integration limit? Theta. Theta is starting from vertical line. So from the vertical line I am moving in this direction. So theta starts from 0 to pi by 2. 0 to pi by 2. Now sine 2 theta integration is cos 2 theta by 2 with a minus sign. Sine 2 theta integration is cos 2 theta by 2 with a minus sign. So minus r by 2 into cos of 2 theta. Okay. Integration 0 to pi by 2. Now once I put theta equals to pi by 2, so cos 2 pi by 2 means cos pi, means cos pi minus cos 0. Okay. So that means it is equals to r by 2. Cos pi is minus 1, cos 0 is minus 1. That means, so here, so there is 1, 2 is missed. So let us check the calculation. So 2 pi r sine theta r d theta, that is there. Sigma is, so m by, so here I write the sigma is equals to m by 2 pi r square, but that 2 is missing over here. No? So that 2 will be there. So ultimately this 2 will not be there. So this 2 will not be there. Got it? This 2 is not there. Okay, so only r sine theta d theta. So in order to make it sine 2 theta, I have to divide it by 2. In order to make it sine 2 theta, I have to divide it by 2. So that means r by 2 into sine 2 theta. Okay. So r by 2 into 2 sine theta cos theta means, now it is correct. Now it is correct. So now ultimately what I am getting is r by 2 only. So the answer is r by 2. Okay. So that means for the disk geometry, I am getting 4r by 3 pi, but for the hollow image sphere, I am getting the value is r by 2 from the center. So from the origin at distance of r by 2, I am getting the y coordinate center of mass. Okay.
Okay.
Now moving on to the next equation. So here I am going for the solid image. Solid means now inside there is a material. So now this is the first geometry that is comes under the 3D. So for this, I should define the rho parameter. Now what is rho? Rho is mass by volume. Now volume of the solid hemisphere is 2 by 3 pi r cube. So 2 by 3 pi into r cube, that is the volume divided by m. So that means 3m by 2 pi r cube, that is our rho. Okay. So if I move inside this, so I can do this by taking two different types of element. First of all, I am taking element by moving r distance and then dr, so that this is basically acting as a shell element. Hollow hemispherical shell. Okay. So for the shell geometry, so if I define the sigma, so what is the dv volume? dv is the elemental volume of the shell. So for this shell geometry, how to calculate the volume? That is surface area into thickness. So that is a method by which I can calculate the volume of this shell geometry. Now what is surface area? That is 2 pi r square. So that is 2 pi r square is the surface area into thickness. Thickness is dr. So that is the dv volume. Okay, that is the volume of this shell geometry. So now what is the mass inside this volume? So corresponding to that, the dm can be written as rho into dv. Now I already calculated the value of rho. What is rho? Rho is basically 2m by 3 pi r cube. Okay. So once I put this number, so that gives the value of dm. So 2m by 3 pi capital R cube into 2 pi small r square into dr. Okay. So ultimately I am getting 4m by 3 r cube into r square dr. That is the dm number. Okay. So once I calculate the dm number, now I can proceed to calculate the value of y coordinate center of mass. So y coordinate center of mass, again formula is y into dm, and in the numerator integration of dm, I am simply writing a. Now again, this y is what? This y is basically the y coordinate of the element. Element is hemispherical shell. So right now I calculate the for the shell geometry, that is the hollow hemispheres, center of mass is at a distance of r by 2 from bottommost position. Okay, so that r by 2 number is basically our y. So what is y? Y is r by 2 multiplied by dm. So inside that dm, 4am by 3r cube comes out, divided by 1 upon m is in the denominator. Okay, and small r square is there, and there is one small r by 2 is there, that is the y number, into dr. Okay, into dr. So integration of this. So ultimately m cancels out. So we are left with 4 by 3 capital R cube. 4 by 3 capital R cube into R cube by 2. R cube by 2 integration dr. Okay. So that means it is r to the power 4 by 4. R to the power 4 by 4 means, so 4 will cancel out. 4 will cancel out. So ultimately, so again I made a mistake. So in the numerator, it is rho is not 2m by 3 pi r. Rho is not 2m by 3 pi r cube. It is 3m by 2 pi r. Nah. So it is not 2m by 3 pi r cube. It is 3m by 2 pi r. That is the correct. Okay. So once I use this 3m by 2 pi r cube number, so here also 3m by 2 pi r. Okay. So it is Cm by 2 pi r cube. So 2 pi cancels out. So ultimately I am getting 3m, 2 pi cancels out. So r cube r square into dr. That is correct. Okay, that is the dm number. So inside the dm number, so let us omit this. So what I am getting, that y is basically r by 2. Y is small r by 2. And what is dm? dm is 3m divided by capital R cube into r square dr. R square dr. And in the denominator, there is one m is there also. M is there. So m is cancels out. Ultimately, m cancels out. So we are left with 3 r cube by 2 r cube into dr. Integration. So r cube means r to the power 4 by 4. That means I am getting 3r by 8. That is the y coordinate center of mass. Okay. Because here the limit is nothing but 0 to capital R. 0 to capital R. So simply I am getting 3r by 8. So 3r by 8 is the answer for the solid hemisphere. 3r by 8 is the answer for the solid hemisphere, where the center of mass is located at a distance of 3r by 8 from the origin. Every time I am calculating from the base, that is from the origin. Okay. So now come to the solid hemisphere calculation again by taking an alternative method. Okay. So first method that we discussed by taking an element which is of shell geometry. Now I am moving a element which is a disk type of geometry. By moving y distance, I cut this disk by a thickness of dy. So this portion is basically acting as a disk element. So this is a disk geometry. Okay, this is a disk, solid disk. So for this disk geometry, I should define the value of dm. Now what is dm? Dm is again rho into dv. Now what is dv? dv is base area into height. Now what is base area? Base area is pi r square into height is dy. There is the dv number. And what is rho? Rho is 3m by 2 pi r cube. 3m by 2 pi r. That is the rho number. Okay. So ultimately it gives the dm number, that is the elemental mass of this disk. So once I got this elemental mass, so now I calculate the y coordinate center of mass. So that should be equal to integration y dm divided by m. Now what is y? Y is again the center of mass of the disk. So disk center of mass is lying over here. Entire disk is there, that is the center of mass position, that is the distance of y from the origin. So simply write y. So y into dm, dm means 3m divided by 2 pi r cube into pi small r squared dy in the numerator divided by m. So again m cancels out. So we are left with pi cancels out. So 3 divided by 2 r cube into y into r square. Y into r square dy. Now there are two variables. Y is there, r is also there. Now you have to replace the y in terms of r. Okay. Now what is r square? R square equals to capital R square minus y square. Applying the Pythagoras theorem. Okay.
Then R is equal to.
Not true, because I am directly applying the small r square. So
Okay.
r, that is 3 by 2 r cube y into small r square. Small r square is r square minus y square dy. One second. Okay. So now it is a single variable of y. Now what is the limit of y? Limit of y is starting from 0 to capital R. No, 0 to capital R. 0 to capital R. So first integration is 3 by 2 r cube. First integration is y. R square into y means y square by 2 means r square by 2. I am writing the limit simultaneously. Okay. Next is y cube. Y cube means y to the power 4 by 4. Y to the power 4 by 4. So 1 is r square, y square, r square by 2. Y square by 2, r square by 2. Right. Then y cube. Y cube means y to the power 4 by 4. That means r to the power 4 by 4. That means r to the power 4 by 2 minus r to the power 4 by 4 means r to the power 4 by 4. That means again I am getting the same answer, that is 3r by 8. Okay. So in both the method you will get the same answer, but the method is different. So first we take a element of hemispherical shell, and the second situation I am taking the element as solid disk. Okay. So these are now come to the hollow cone. Again this is the geometry which is basically a 2D geometry. Okay, 2D geometry. Whenever the geometry comes on the hollow category, every time we assume it is a 2D geometry. Why? Because here also I am taking the thickness of this. Thickness of this cone is very small. T is very small. Okay, so only thing is that it is made of, let us say, you roll a paper and you make a hollow. So that means the thickness of the paper is very small. So that means now I can assume this as a hollow cone. And for the hollow cone, I should define the parameter as sigma. What is sigma? Mass by area. What is area? Area is the surface area. Now what is surface area? Surface area is pi r into L. Pi r into L. What is the L? L is the slant height. L is the slant height. R is the radius of the cone. Let us say this is the cone. Okay, let us say this is the cone, and let us say this is the r distance. This is the r. radius, and this is a slant length L. You move at a distance of y. You move at a distance of y and take a ring-like element like this. So once you cut this cone, it gives a ring. So it is a ring type element. Okay, this is the ring element. Now, how to locate the ring? So in order to locate the ring from this point, you move a distance of x. Okay, move a distance of x, then take a thickness of this as, let us say, dx. Okay, so thickness of the ring is dx. I am assuming the thickness of the ring is dx, and let us say this vertical angle is theta. Okay, let us say this vertical angle is theta. So for this ring geometry, let us say this is the r radius. So what is r? R can be written as x sine theta. R is equals to x sine theta. No, R is equals to x sine. So for this ring, I want to calculate the dA first, area. So area of the ring should be equals to 2 pi r is the perimeter into dx. No, area of the ring is 2 pi r is the perimeter of the ring multiplied with the dx, that is the width of the ring. So what is smaller? Smaller is x sine theta. So 2 pi x sine theta into dx. Okay, so that is the dA. So corresponding to this dA, now I can write the dm number. What is dm number? That is sigma into dA. Sigma into dA. So what is sigma? Now before that I should write the value of sigma. So what is sigma? Sigma is equals to m by area. Area is what? Pi r into L. What is slant length? So this is called the slant length of this cone. So let us say this is L length. So what is L? L is basically our x number. Or I can say if the height of the cone is given, so L should be equals to h square plus r square square root. So I can write the m divided by pi r into under root of h square plus r square. Okay, that is the sigma number. So once I got this sigma number, put it over here. So finally I can simplify this dm number. What is the dm number? Dm is m divided by pi r into under root of h square plus r square. H square plus r square, that is the sigma number, into dA means 2 pi into x sine theta into dx. So further simplification, pi cancels out. So I am left with m by r 2m into x, and the denominator is h square plus r square, that is also constant number. H square plus r square number is also constant number, multiplied by x sine theta into dx. So this is the, finally I am getting the value of dA. Now I can apply the formula for the calculation of center of mass. Center of mass of this y coordinate of center of mass should be equals to integration of y dm divided by total mass, that is m. What is y? Y is the center of the or center of mass of this element. So element is situated over here. Center of mass is the distance of y. So simply y. So inside this dm number, so this part is all constant. This part is all constant. Sine theta is also constant because theta is not changed. So only variable is x. Only variable is x. So let us say I am saying this number is alpha. Alpha into x dx. Now what is alpha? Alpha is basically, I am saying that alpha is equals to 2m divided by capital R under root of h square plus r square, h square plus r square into sine theta. This number is our alpha number. Okay, so that number is entire constant, so that will not take part inside the integration symbol. So we are left with that. So only alpha into x times dx. So in the numerator, so y is what? Y is y. Y is y. Y is not changing. So how to write y in terms of x? So for that, y is basically can written as, so this vertical height is, then this is equals to how much? This is equals to h minus 1. So for the upper triangle, if I calculate this r square, for the upper triangle, can I write x square should be equal to small r square plus h minus y whole square? Nah. Yes, square is the hypotenuse part, r is the this part, and vertical part is h minus 1. So from that I can get the expression of the y. Okay. Now what is r? R is basically x sine theta. So ultimately I can write x square equals to x square sine square theta plus h minus y whole square. Okay. So that means h minus y whole square should be equals to x square into 1 minus sine square theta. and 1 minus sin square is cos square theta. So x square cos square theta. Okay. So that means h minus y should be equals to x cos theta. If I take the root of both sides, so h minus y is equals to x cos theta, or I can write y should be equals to h minus x cos theta. Okay, so this is the y number. So once I got the y number, now we can put inside the integration side. So what is the integration? So y for the center of mass should be equals to y means h minus x cos theta multiplied by dm. Now what is dm? Alpha into x dx. Alpha into x dx. Integration divided by m. Now only thing is that variable is under x. So your limit should be for the x. So what is x limit? Start from 0 to slant length L. Okay, 0 to L. So limit is from 0 to L. So now I take alpha by m in the outside part. So integration is h minus x cos theta into x dx. Okay, so 0 to L. So ultimately I am getting alpha into m, h into x means h, x square by 2 means L square by 2 minus x square means x cube by 3 means L cube cos theta by 3. That is the answer that I am getting. Okay, so this is the final answer of the y coordinate center of mass in terms of the alpha, m, L, all those things. Okay, now put all those numbers. So alpha, I have already defined the alpha number. So once I put the alpha number over here and further simplification, putting this h square plus r square, this number in the denominator is basically 8. So you can simplify this alpha number by saying that it is basically 2m sin theta divided by r into 8. That is the alpha number. Okay, that is the alpha number. So once I introduce this alpha number and put it inside this bracket, ultimately simplifying this, I will get the answer as simply h by 3. Okay, so this is the only geometry. Holocone is the only geometry whose calculation is somewhat complex. Okay, all the other calculations are very much simple, but only thing is that holocone is the one geometry where you have to do a lot of calculation. But once you do the calculation, the answer is quite simple, that is h by 3. What is h? H is the height of the cone. So from the bottommost point, you have to move by a distance of h by 3 so that you can get the y coordinate center. Understood? Now come to the last geometry, that is the solid cone. So again, for the solid cone, it is a 3D geometry. It is a 3D geometry. So for 3D geometry, I know that I should define the rho number. So rho is what? Mass by volume. Mass by volume. What is the volume? That is 1/3 pi r square into h. So m divided by 1/3 pi r square into h. So h is the height. So ultimately I am getting 3m by pi r square into h for this solid cone. So once I define the rho parameter, now in order to make the solid cone, so what I am doing, I am moving a distance of y from the bottom position and take an element like this, whose thickness is dy. So this element is nothing but a disk. So this is a solid disk. So for this disk, let us say the radius of the disk is r. The radius of the disk is r. So let us say this is the disk radius is r. So for this disk radius, the dv should be equal to what? Pi r square into dy. Pi r square is the base area, dy is the thickness of the disk. So pi r square into dy will be our value of dv. Okay. Now what is r? So for that r, so this vertical distance is our h minus y. H minus y. So there are two triangles which are similar to each other. So this is the r number, capital R number. So if I do the similar triangle analysis, so can I write small r divided by capital R should be equals to h minus y divided by h. Okay. So from that I can get the value of small r. So small r equals to what? R into 1 minus y by h. That is the smaller number. So once I got the smaller number, now I can calculate the value of dv. So dv is what? dv is equals to pi into small r square means capital R square into 1 minus y by h whole square into dy. This is the dv number. Once I know the dv number, then I can calculate the dm number. What is dm number? That is simply rho into dv. And I know that rho equals to 3m divided by pi r square h. is a dm number, a row number into dv means pi r square into 1 minus y by h whole square into dy. Okay, so once I simplify this, so pi r square cancels out. So I am left with 3m by h into 1 minus y by h whole square into dy. So that is the dm number. So once I convert the dy, now I can write the y coordinate center of mass. That should be equal to integration of y dm divided by m. Okay. Now what is y? Y is again the center of mass of the disk. So disk center is at a distance of y from the origin. So simply write y. Okay. So it is written as y. So ultimately m will cancel out. So I am left with 3 by h number into y into 1 minus y by h whole square into dy. Okay. So once I put the limit of y, what is the limit of y? Starting from 0 to capital H. 0 to capital H, the y limit is there. So once I simplify this, if you do the simplification, so ultimately you will get the answer as h by. Okay. So this is the final geometry, that is a solid cone. So for this it is h by 4. For the hollow cone, it is h by 3. Okay. So this is how you can get all the geometry. So this is the final center of mass figure. So semicircular ring, hollow hemisphere, hollow cone, disc, hemisphere, solid cone. So there are 6 geometry that you should remember about the property how the center of mass is vary from different geometry. Understood? Now we should move for calculation of center of mass if the object is added up or subtracted. Okay, that means now in this situation, what is that? So you know the basic definition. So you know what are the defined geometries are there. 6 defined geometries are there, and correspondingly, I know what are the defined formula for calculation of the center of mass for all those basic geometries. Now I want to calculate the center of mass of the combined body. Combined body means what? There are 2 different geometry. One is a square plate added with a semicircular disc. So this is a square plate. This is a square plate added with the disc geometry. Okay. If nothing is stated, assume that both are made of same material and the material is uniform. That means for this geometry, I should say sigma is, let us say sigma is there. So for the square, let us say is the first geometry and disc is the second geometry. Can I calculate the mass of the first geometry m1? What is that mass? Sigma into area. What is area? A square. What is mass number 2? Mass should be equal to sigma into area. Area is radius. What is the radius? Radius is a by 2. This radius is a by 2. This radius is a by 2. So pi r square by 2 means pi a by 2 whole square by 2. That is the m2 mass. So once I calculate the m1 and m2, now I can say that entire mass that I have calculated is for the square plate, it should be at the origin over here. And for this geometry, it should be at a distance of 4r by 3 pi. Yeah, I know that this distance is how much? Center of mass for this geometry is at a distance of 4r by 3 pi. So this distance from this vertical line should be equal to 4r. R is a by 2 by 3 pi. That means 2a by 3 pi. Okay. So now the problem is somewhat simpler. So here the mass m2 is there. Point mass m2 is there. And here the mass small m1 is there. Now this m1 and m2 are the 2 discrete point mass which are being separated by a distance of r. What is small r? Small r, can I write? This distance is a by 2. This distance is a by 2. The small r is a by 2 plus 2a by 3 pi. Okay. So once I know the small r, now the center of mass for the 2 particle system formula can be applied. Let us say this is the final center of mass. So final center of mass from this m1 position, let us say I want to calculate this r1 number. Now what is r1? R1 should be, I am taking the distance from m1, so in the numerator m2 will come, denominator m1 plus m2, multiplied by total distance, that is r. So I know the value of m1, I know the value of m2, I know the value of r, so all are known, so I can calculate what is the r1. So this is how you have to calculate the center mass for the combined system. When the bodies are added together, then it is called the combined body. So for that you have to add the masses m1 and m2. There may be another object. I can add another mass. with that body, so then it will be m3. Okay, but if nothing is stated, assume that sigma is constant for this. So then only I can approach the formulation. Now, there is another variety of problem where you are subtracting the mass. There is another variety of problem where you are subtracting the mass. That means there is square plate from which you are cutting a hole. Okay, from which is cut the hole. So for that, first of all, you have to understand that one mass is, let us say, this mass is like this way. Entire mass of the square plate, let us say m1. And another mass is the m2 mass, that is the disk mass. Okay, so if I say sigma is given, so for this m1, can I write sigma into area? Area is how much? 4a whole square. That is the m1 mass. Okay, and for this, radius is how much? This is 2a, so radius is a. Radius is a. So here the radius is a, so m2 can be written as sigma into pi a square. Okay, sigma into pi. So once we calculate the m1 and m2, that means I am saying the entire mass m1 is there and m2 is there. But in reality, what is happening, m2 is not a positive mass, it is a negative mass. Why? Because m2 mass is subtracted from the m1. So I should say that the center of m1 is over here, the center mass, and m2 center mass is over there. Okay, so in the basic geometry, this is the m1 center mass, this is the m2 center mass. What is this distance? That is called the arc. Okay, so for this situation, what we write, that here is m1 and here the m2 mass is there, but that m2 is not positive, it is negative. Why negative? Because the mass is being subtracted. So m1 and m2 separated by a distance of small r. What is small r? Small r is a. Okay, small r is a. So now the center mass, final center mass from the from the O point or the m1 point, let us say this is the point. So let us say this is the r1 distance. Now what is r1? R1 should be equal to m2 by m1 plus m2 into r. But put it with the minus sign. So m2 should be taken to be a negative sign. So m2 should be negative in the numerator, m2 should be negative in the denominator. So finally what you can write, minus m2 into r divided by m1 minus m. Okay. So the same formula can be used. Whenever we are adding the mass or whether I am subtracting the mass. Both are giving the same result. So whenever there is a combined body system, so in combined body, either mass may be added up to get the combined effect or mass will be subtracted. So depending on the situation, I initially calculate the mass, individual mass of m1 and m2. Once I got the m1 and m2 information, now I can apply the same concept to calculate the center mass of the combined body when they are separated by a certain distance. Okay. So this is all about the center of mass calculation. Okay, so far we discussed about the different variety of center of mass calculation. Now we solve some of the numerical. Yes. So let us do this. So there are two geometry. One is the ring and there is the disk. Okay. So mass of the ring is given as m. Disk is mass given as 2. Okay. So now you are asked to calculate the center of mass of the combined geometry. So for the basic geometry ring, I know that the center of mass will be over here at a distance of 2r by pi. So this distance is 2r by pi. And for the ring, it is at a distance of 4r by 3 pi from the origin. Okay. So for the ring, it should be at a distance of where? Here, this distance 4r by 3 pi. 4r by 3 pi. Okay. So now, at this position, the 2m mass is concentrated. At this position, the m mass is concentrated. Okay. So you are asked to calculate the center of mass based on the coordinate point O. Origin is this. So based on O point, you have to answer the coordinate of the corresponding center of mass. So let us say, so there are 2 point particle. So m is there, 2m is there. The separation between them is known as the R number. What is R number? Or rather, you give the coordinate. You give the coordinate. This coordinate is minus 2r by pi, comma 0. And this coordinate is 4r by 3 pi, comma 0. Okay. So once I write the coordinate, so based on this origin, I can directly get the answer. So what is the x coordinate of the center of mass? That should be equals to m1 into x1 plus m2 into x2 divided by m1 plus m2. That is the formula that I am going to use. So only x coordinate has to be calculated. Why? Because the y coordinate both are 0. So minus m into 2r by pi plus 2m into 4r by 3 pi. And the denominator 2m plus m means 3m. So ultimately what I am getting that 8m r by 3 pi, 8m r by 3 pi minus 2m r by pi divided by 3m. So in the numerator it is 2m r by 3 pi. So if I multiply this by 3 and 3, it is 6. 8 minus 6 is 2. So 2m r by 3 pi divided by 3m. So cancels out. So I am left with 2r by 9 pi. Okay. So that is the exponent. So answer is 2r by 9 pi comma 0. Okay, that is the final position of the center. So center of mass is always shifted towards the heavier mass. That is the towards the 2m mass. So now the final center of mass is over here. So this is the position of the final center of mass where is the towards the heavier mass, because I am getting the final center of mass as positive number. So this distance is 2r by 9 pi from the origin. That is your answer. Okay. So there are two rods of mass AM and 2M of length L are joined as shown in the figure. Find the center of mass. So for this, so take as this is the origin. So for the first rod, this is the center of mass. So what is the coordinate? That coordinate is L by 2, comma 0. For the second rod, the coordinate is over here. That is 0, comma L by 2. Okay, so once I write these two coordinates, now I can calculate the position of x center of mass and y center of mass. X center of mass should be equals to m into L by 2, m into L by 2 plus 2m into 0 divided by 3m. That means L by 6. So x coordinate is L by 6. So y coordinate is m into 0, then 2m into L by 2 divided by 3m. That means I am getting L by 3. So L by 6 and L by 3 are the coordinates. That means finally your center of mass will be somewhat over here. L by 6 means this much distance and L by 3 means this much. So let us say this is the position. So center of mass may not lie within the body. It is outside the body. Okay. So final answer is L by 6 comma L by 3. Understood? Okay. Like this. Now there are two geometry again clubbed together. One is a solid cone and the solid hemisphere. Okay. There is one solid cone and the solid hemisphere. They are joined together and all those density materials all are given. So depending on that, you are asked to calculate what is the final center of mass based on this origin position. So this is the origin. With respect to the origin, you are asked to calculate what is the position of the center. So before that, you have to calculate the mass. So let us say mass of the cone is how much? Mass of the cone is 1 volume into density. Now what is the volume? That is 1 by 3 pi r square into h. So let us say this is the h number. Let us say this is the h number. This is the h number. H is the height of the cone. Okay. So if this is the h and this is the radius of the cone is given. So similarly, I can say the radius of the solid sphere is also r. So volume of the cone is how much? 1 by 3 pi r square into h. That is the volume of the cone. So mass of the cone is how much? Mass of the cone is into density 1 by 3 pi r square into h into density is rho c given. Okay. So this is the mass of the cone. Now similarly, mass of the cylinder, mass of the sphere. So mass of the sphere is 2 by 3 pi r cube. 2 by 3 pi r cube into rho s. Now in the question it given the rho s is 2 rho c. So put it 2 rho c, 2 by 3 pi r cube. 2 rho c. Okay, so this is the MS number. So once I calculate these two masses, now I can point what is the coordinate of the center mass. For the solid cone, I know that it is at a distance of from the base of the cone, it is at a distance of h by 4. So this is at a distance of h by 4. And for the solid sphere, it is at a distance of 3r by 8. This is a distance of here, the center mass is at a distance of 3r by 8. Okay. So So there is a relation between H and R because the angle is given as 37 degree. Okay. So use that relation. That means tan 37 is equals to R by H. Can I say tan 37 R by H? Okay. And tan 37 means 3 by 4. Okay. So H is equals to 4 R by 3. H is equals to 4 R by 3. Now put it over here, MC number. So if I put H equals to 4R by 3, so finally I got the MC equals to mass of cone equals to 1 by 3 pi R square into H is 4R by 3 into rho C. So ultimately I am getting 4 R3 pi by 9 into rho C. Okay, and this is also the same number 4 pi rho C by 3. So that means this number, if I say m, so it should be 3m. It should be m by 3. No. So if I say one mass is m, then another mass is m by 3. Now, what is h by 4? H by 4 number is nothing but r by 3 number. This is r by 3. Okay. Now there are two particles. One is situated over here, another is situated over there. So finally, y coordinate center of mass, yc can be written as mass of the cone into r by 3 plus mass of the sphere into minus 3r by 8. Why minus? Because I am moving downward from this origin. Okay, divided by mc plus ms. Now mc is what? mc is m by 3. m by 3 into r by 3. Okay. ms is what? ms is what? m. So minus 3m r by 8 whole divided by m plus m by 3. Okay. So in the numerator mr by 9 minus 3mr by 8. So mr by 9 minus 3mr by 8 whole divided by 4m by 3. So 72 is the LCM. 8 minus 27. Nah, 8 minus 27. That means minus 19. Minus 19 R. M will cancel out. Here another 9 is there. No, not 9, is 4. And 3 is there. Okay. So 3 and 72 means 24. 24 into 4 means 96. So minus 19 R by 96. Minus 19 R by 96. That is your answer. Okay. That is option number B. Okay. So this is how you have to calculate for the combined bond. Okay.